Let's go for problem number 5a. This is the problem number 5a. They have given cantilever type beam with roller support. Let's go for Ansys. Preferences. It is structural analysis, structural H method, OK. Preprocessor, add, add. It is a beam with 2 node 188, OK. Pros, and there is no real constant. Material properties, material models, structural, linear, elastic, isotropic, and Young's modulus is they have given 200 GPA and everything is in meters, so try to keep in GPA only. That is 2E11, and this is 0.3, that is Poisson's ratio, and only one element, so only one material properties. Close. Go for sections, beam, common sections. Uh, Make sure it is of some rectangular, that is height into breadth, and they have given breadth is equal to that is width is equal to 0.15 meter and height also same 0.15 meter. Click OK. Next go for modeling. Create key points in active CS as usual. First key point at origin, apply. Second key point, it is 4 meter away from the origin, and third key point is 8 meter away from the origin. Click OK. Create lines, straight line. Select first and second and third key point, and go for meshing. There's no mesh attributes because there is no real constant. Go for size control, manual size, and lines, picket lines. This line, say it is about 20 divisions. And again lines, picket lines. This line, this also say about 10 divisions. Go for mesh tool, mesh, select both the lines, click OK. Now preprocessor is done. Go for solution, define the loads by apply loads, structural displacement on key point, select first key point. As we can see here, the first key point is of cantilever type. There is no movement along XYZ direction. Therefore, select first key point, click OK, and give all degree of freedom is equal to 0. Click OK. Again, go for apply same structural displacement and key point. Select second and third key point, and here we can see this is type of roller type, so there is no movement along y direction. So give uy, select only uy is equal to 0, click apply. Here uy is 0 because movement along y direction is 0 but along x direction is not 0. Go for pressure because it is of UDL. UDL means uniformly distributed load, which is pressure on beams. Here on beams, and select first first element and all divisions. Deselect this one. Try to select it. Make sure all 20 elements has been selected. Number of divisions you give, that much of divisions you need to select for each element. and first one it is of pressure, and always remember this load key should be 2, and pressure value at node I should be, as usual they are given 12 kilonewton per meter, 12,000. Click OK. Close. Again on beams, pressure on beams, select all element from this one. It is only 10 divisions, right? So 10 divisions will be selected. Make sure everything is selected in second element. OK. Here also load key 2, and pressure value at node I is, they have given 24 kilonewton per meter. So 24,000. Sure. See, all direction down, facing downwards, so don't give while giving the pressure, don't give the sign, negative sign, because pressure by default it will be in downwards. If you give negative sign, it will be in upward direction. Next solution, defining load is over, solve current ls. Okay, close. Now we need to plot result. Go for general processor, plot result, contour plot, nodal solution, and degrees of freedom. In Y component, deform shape only, click OK. This is how it will look. You can check the result for nodal solution for problem 5a. Yeah, it is correct. Next, here they will ask for plot the SFT and BMD. So you need to go for defining the table. As usual, plot result, contour plot. Here element table has to be defined, right? So go for element table, define table, add. Here be careful, you need to select by sequence number, and instead of ls, SMISC. And for SFT, always remember you need to define two table items by sequence number SMIC 6. Click on apply, and again by sequence number SMIC 19. Click on apply. This both table items what we have created is for SFT 6 and 19. Now we will create element table items for BMD by sequence number SMIC. BMD it is 3 and 16. First 3, and again by sequence number SMIC 16. Click OK. Once again I will tell you, create the element table as usual by sequence number SMIC 6 and 19, two table items for SFD, and 3 and 16, two table items for BMD. Close. And again as usual go for plot results, and here last time we are creating ls1, so we are taking element table. Here there are four element line element table, so go for line element results, select 6 and 19 for SFD. At node I SMIS 6, and node J SMIS 19, that is 19 for, and undeformed shape. Click on OK. This is how SFT for this 5-way problem look like. And to plot a BMD, again go for plot as a control plot, line element result, but you have to change for 3, and at node J 16. Okay, this is a BMD. And as usual, if they have asked for reaction stresses, reaction results, go for least results, reaction solution, all items. Okay, these are the reaction solution. This is how we will solve the beams problem 5a. Thank you.